In this lesson, we're going to cover Euler's method. We have a note here. It says the basic idea behind slope fields can be used to find numerical approximations to solutions of differential equations. Mathematician Leonhard Euler had the idea to improve on a linear approximation by using the following method. For Euler's method, you're going to start with a point given by the initial value and proceed in the direction indicated by the direction field. After a short time, also known as a step size, we're going to look at the slope at a new location, which is the slope field, and proceed in that direction, repeating the process. In order to apply Euler's method, you're going to need an initial point, you're going to need a rate of change, dy dx, or the slope, and then finally you want to identify the step size. It's referred to as h, or change in x. So here's a basic diagram that's happening in Euler's method. You have your curve, and this is the exact solution to the differential equation. You have your initial point right here, and then you have a tangent line approximation, and then it gets adjusted. So here's your step size, your change in x or h. It gets adjusted again, and that will give you Euler's approximation. This example says given y prime equals 2x plus y, and also we're given y of 0 equals 1. Use Euler's method starting at x naught equals 0 with step size 0.1 to approximate f of 0.3. So you notice we have a table set up here. The first column is going to be x, then y. Right here we have dy dx, or the slope, and you times that by change in x. When you multiply those, it gives you change in y. And finally over here, you take this y plus change in y and you add them together. Once you get that, you drop it down over here and then you do the process again. So the first thing when filling out our chart, we want to look at our initial condition. So it says to start when x is 0. So we're going to plug in 0 right here. And then you have that y of 0 equals 1, so that means when x is 0, y is 1, so we can plug in a 1 right here. Next it says the step size is 0.1, so that's the same as h, or change in x. When you start at 0 for x, and then your change in x is going to be 0.1, that means when you go 0 plus 0.1, that gets you to 0.1. Then you add 0.1 again, so that gets you to 0.2. And then you add 0.1 one more time, and you get 0.3. And again, we're trying to approximate f of 0.3, so we just need this y value right here that corresponds to this 0.3 for x. All right, so now that we have our initial point, and we have our derivative or slope formula, and we have change in x, we can go ahead and start the process. So right here it says to take the derivative, which is 2x plus y. So we're going to go 2, and then we plug in this x, and then we add the y value, which is 1. And we take this and we times it by change in x, which is 0.1. So here we have 2 times 0 is 0, 0 plus 1 is 1, and then we multiply that times 0.1, which is just 0.1, and 0.1 is now our change in y. So again, over here in this column, we add this y and this change in y. So when you add these, you get 1.1, and we're going to drop that down over here. So 1.1 goes right here. And now we start the process over again. We have x is 0.1, y is 1.1. We're going to plug them in first to the derivative, which is this formula right here, and then we times by change in x, which is 0.1. So we have 2 times 0.1 plus 1.1, and then we times all of that by 0.1, and that equals 0.13. So finally, we take this y value and we add it to 0.13 over here, and when we add these together, we get 1.23, and we're going to drop that value down here. And now we're going to start the process again. We're going to take 0.2 for x and 1.23 for y and plug it into our slope. And then we times all of this by 0.1. So you end up getting 0.163. And now we add y and change in y over here. So we go 1.23 plus 0.163, and that makes 1.393. And this was the y value we were trying to find. So I'm going to write that down below. So f of 0.3 is approximately equal to 1.393. This example says consider the differential equation dy dx equals y over 3 times the quantity x minus 2. Let y equal f of x be the particular solution to the differential equation with initial condition f of 0 equals 2. Use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f of negative 1. So again, we have our Euler's method table set up, so let's start plugging things in. We're starting at x equals 0, and we're given that f of 0 equals 2, so we have 0 and 2 for x and y. It says we need 2 steps of equal size to approximate f of negative 1. So you want to think of this as you're doing one step and then another step, and we're trying to get to negative 1. So to find your h, or your step size, or it's also change in x, you can think of it as b minus a over n. You're starting at 0, and you need to get to negative 1, so that's going to be your a and b. and n is the number of steps. So you get -1/2 as your change in x. So you're going 0, and then you add -1/2 to get to -1/2. Then you add -1/2 again to get -1. So here's our slope formula, so we're ready to plug everything in. We have 0 for x, 2 for y, we're going to plug them into this. Again, our change in y is -1/2. So right here we have -2, we times that by 2/3, so that makes -4/3. And -4/3 times -1/2, that's going to make +2/3. Next we take this 2 and we add it to 2/3 over here. And we drop that down right here. So now we're ready to start again. We take -1/2 for x and 8/3 and we plug it into the slope formula. Since we're plugging in 8/3 right here, it's 8/3 and you're dividing by 3, which is the same as timesing by 1/3. Then we're plugging in -1/2 right here for x. And we times all of this by our change in x, which is -1/2. Okay, so I'm going to work this out down here. So 8/9, and this is -2.5. or -5/2. And 8 reduces with 4 to just make 2 on top. So we get 10/9. And we're going to add 8/3 plus 10/9 over here. All right, finally we need a common denominator, so we're timesing this by 3/3. So we get 24 plus 10, so that's going to be 34/9. All right, so there's our value we needed. So using Euler's method, we get that f of -1 is approximately equal to 34/9. Alright guys, thanks for watching!